So generally speaking, if you have your y equals to natural log is the log of the base of e, right? Ax plus b. So if you got something like this, so your dy by dx, is a over ax plus b, right? It's as simple as that. It has got an exception as a condition here that your x should always be greater than minus b over a. So let's quickly try to solve it. How do I get it? So let's say I've got log e of x square plus 2. Log e of x square plus 2. Just before that, if you have y equals to simple, I say log x, then your dy by dx is 1 over x, right? So these are the two things that you need to take care of. And let's say even if it is a kx, even if where k belongs to a real value, k belongs to all real values. So these are the two important things that you need to take care of. Now let's try to find the log of the differential of this logarithm. I just use the standard chain rule. I say, okay, x square plus 2 is u. Romeo, is it making sense?
Yeah.
So then what does y becomes? Log of u. Yes, Ayushka? Chris, yes?
Yeah.
Yeah? I've just used the chain rule. So here I'm saying chain rule. Alright? Now what does chain rule tells me? Chain rule tells me that dy by dx is dy by du times du by dx. Yes? This is u and that's my function dy by du. Let's find the dy by du here. 1 over x, which is 1 over u. Correct? Anushka, yes?
Yeah.
And what is du by dx? Let's quickly find du by dx here. It is 2x, right?
Yeah.
And then I just multiply them. This multiply by 1 over u. And what is u? 2x over u was x square plus 2. That's the answer. Right? Got it?
Mm-hmm.
Now just look at this. Whatever is here comes as a denominator. Whatever is here has come in as a denominator. What's a? A is the differential of this function. The expression inside, ax plus b, should give you a. The differential of this function comes here. Does that make sense?
Yeah.
Yes? So that is what logs are all about. The differential of this function comes as the numerator over whatever this expression is. And in general, if now let's quickly apply this here. The differential of this function, Ayushka, what is the differential of kx?
Okay.
K over whatever is this. That's dy by dx of log x, correct? Chris?
Yeah.
And you cancel x by x. That is why 1 over x is the answer. Does that make sense? So everything has a reason. Why y equals to log x is 1 over x? Because that's the rule working behind it. Alright? All good? Yes or no?
Yeah.
And no one asked me this question. No one asked me this question. Why? Why the hell you've got this condition here?
Domain. Is that the domain?
Sorry? That's the domain, but why is this domain? Why is this minus b over a? Why?
Because it wouldn't exist like if it
Exactly. So if your x is equal to this value, so what will happen? What will happen to this log? Log e a, and your x is, let's say, minus b over a plus b. A cancels, so it becomes log of 0, right? Sorry, log of 1. Yeah, 0. B cancels. So if your x goes below this, so this becomes a negative value. And you don't have logs for negatives. Right?
I have a question.
Yeah.
Why is a the numerator for the question?
This one?
Yeah.
Because that's the rule for the log of, that's the rule for the differential of this log.
So it's just whatever is attached to the x.
I should say here f dash of, let's say this is u, f dash u. Whatever is here, you find the differential of that. Here I've got ax plus b, so differential is a. So whatever is here, the differential of this over this bit. We just saw here. We just saw here, where? Here. You haven't got anything in a is 1, right? But I found the differential here is 2x. So 2x came on top, stuck, and that expression came underneath it. All good? Straightforward, right? No dramas there. So if I were to quickly then summarize it, and I take all of that complexity off the board and give you even more simpler a rule for logs, I can say that, let's say there's a function h of x which is log of a function, right? This is what we had, right, Ayushka? Look here. Now, so what is h? The differential of this. The differential of f dash x over differential of f of x over f of x. That's what we just did, right? So that's what the rule is for the logs. I wanted to explain you, right?
That's only for natural log, yeah.